Everyone, happy to be here. Today we're going to talk about AI agents. It's the talk of the town, and especially about our approach to supporting the building and deployment of AI agents in a data-centric and production-ready way. So thank you, Darren, for actually setting up a lot of this. You've mentioned some of the kind of problems that we face when putting not only models, but also kind of more complex applications into production and getting value in a production environment. So first, a quick definition about AI agents. So the way I would define an AI agent is a complex application that uses AI models to automate the execution of tasks in service of kind of a larger goal. And so you can imagine, here's kind of a classic example of a customer support agent that can interact with a user, but not only that, execute on pieces of functionality in order to resolve some sort of query from a user. So here in this example, you can see a user asking a customer support agent about help for an order. That agent is then able to itself decide to retrieve additional information about that order based on the inputs from the user, as well as execute an additional piece of functionality, in this case, issuing a refund. So agents need to have an overall goal, something that they're trying to achieve, tools or functionality that help them achieve that goal. That often comes in the form of an API or a piece of code that LLM can then route to execute. And then it needs the ability to reason about the progress against that goal, and a kind of decision-making framework about how to step-by-step achieve that goal using the tools that are available to it. So we'll go through a quick example. This is the example that I showed on that first screen of kind of a customer support agent with two simple tools. So you can imagine a user asking this agent about an order of theirs. That query will then flow into prompt, and that prompt is usually used to do many things, but some of the main things will be define the goal of the LLM and of the agentic system, tell the LLM what tools are at its disposal and what those things can achieve in service of the overall goal of kind of resolving this query from the user. But it can also do things like add guardrails or define kind of tone of voice and how an LLM overall should be approaching the problem. So then you have the ability for the LLM to decide which tools it would want to call. So in this example, based on the query from the user, as well as the system prompt defined by whoever built the system, the LLM can then decide that this get order info is kind of the first step to working through this problem. And that would be kind of defined through the prompt in this example, where you're telling the LLM, if you're going through some sort of query step by step, before you're able to execute on some actions, you need to get additional info. And so in this case, the tool is, querying a database and returning information back, maybe about an order or about the user. And then as it flows through this kind of logical framework, it is able to issue credit or a refund in this example. The other thing to note here is that the system needs memory. And so that memory is not just memory about kind of the inputs and outputs to the LLM, but it's memory about the inputs and outputs of every kind of component in this kind of modular application. So you can imagine, first you have your kind of user query that's being sent to the LLM, but then you also have each tool call that is being made, what the status of that call is, what the result is, and step by step, you want the ability to kind of enable the LLM to know what has been done over time as it kind of iteratively goes through this decision-making process. So this sort of application, an AI agent, is relevant in a lot of domains. Obviously, it's a very nascent field, and so we're still kind of trying to understand where the value is. But some examples that are already kind of you can already kind of see in the market are things like customer support agents, coding copilots, automated data analysis, knowledge bots that are able to kind of interact with a user, but also retrieve information to kind of enhance the responses. as well as kind of marketing agents that are able to take actions like creating content. And we'll actually kind of go through an example of that in a bit. So now we kind of move, let's talk a bit about the challenges in design, in not only designing and building agents, but taking agents from kind of a POC and putting them into production. And this is, I think, where we at Seldon kind of focus. It is the ability to take the design of an application, but put it into a system that can handle high traffic, that's very observable. And those are things needed when you take something from kind of a minimal project that doesn't have to handle a lot of usage, and putting that into a system that can handle thousands of requests per second. So there's three parts of this, I would say. One is the kind of design and the building. Two is the observability, so the ability to know what is happening, when and why, in order to be able to reason about the performance of such an application and improve it over time. And then there's production ready. So we'll go through all of these kind of topics one by one. So first, there is the kind of process of designing and building an agent. And it's not very different to kind of a more traditional software application. But in this case, you're using these kind of LLMs as components that are making decisions within that kind of modular application. So in order to build an agent, you need to be able to have an LLM running. So you can either use a third-party service like OpenAI or Gemini, or if you choose to do so, you could deploy an LLM locally. And so the ability to do that is kind of, you need to be able to do that using either approach in order to build an agent. And then you also need to be able to connect that agent, that LLM, to tools. And those can be APIs, they can be custom scripts or code that you want that LLM to be able to execute. And as part of that, you need to kind of build out the orchestration logic that allows an LLM to actually route to a given tool or API or script, given the information that's provided to it. And then also you need memory. So you need the ability to kind of store information as you're going through an iterative decision-making process. So in terms of designing and building agents, there are some kind of popular frameworks that are out there in order to do this. So we kind of mentioned already today LangChain. And LangChain, what LangChain does is it provides kind of a Python-first framework to kind of do the building. So deploy an LLM, set up tools that LLM can call, and set up the orchestration logic that ties those all together into a larger application. However, a lot of those frameworks, where they kind of might fall short is around the observability and production readiness. So there are a lot of things that a builder would need to think about as they're taking an application that they've built that can kind of prove value in kind of a small scale, taking that and putting it into a very high scale, high traffic environment. In terms of observability, I like to split it up in terms of operational monitoring and performance monitoring, where you can think about operational monitoring as kind of getting a good understanding of the system and its performance from a kind of engineering point of view. So when you put an application into production, you really want to understand what the latency and throughput profiles of that application are. And also kind of understand the resource utilization so you can manage costs. You also want to have logs about the status of the various components that you have in your application in order to understand, is it kind of stable? Is it working well? Is it able to scale up and down as needed? Is it kind of using the appropriate amount of resources? So all of those things are quite important in order to be able to manage this type of application in production. And then you have performance monitoring. So this kind of covers a very wide range of approaches. At the very kind of base level, you need the ability to kind of track requests and responses. What are the different services within my application doing, and what are the predictions that are being made. But then past that, you ideally want to have ways of assessing performance. And there are a lot of different ways in which you can do that. You can look at things like drift detection and outlier detection and explainability as kind of monitoring components that help you understand the performance of machine learning models. But then for LLMs, you also have other kind of approaches that allow you to monitor. So for example, you have LLM-based evaluations where you can ask an LLM to make an evaluation of a certain output based on different kind of aspects that you might want to evaluate. Or you can have heuristic metrics that allow you to take an output and understand specific aspects of it. So for example, does this text contain a certain string, or is it properly formatted as a JSON file or something like that? And next, we'll talk a bit about production readiness. So I think the main thing here is that if you consider an application that you develop with a framework like LangChain or just kind of something that you've created in a Jupyter notebook that just kind of works, it's able to call an LLM and have that LLM call different tools. Taking that application and putting it into a system that can handle high level of traffic, that's what we all talk about as this kind of gap, that this gap between kind of a POC and something that can really work well in a production, in a high scale system. So some of the things that you need to kind of think about in order to put something into a high traffic system and ensure that it works well and robustly are scaling, self-healing. So, the ability to, if you have a service that falls over and fails and stops working, the ability for it to come back to life automatically. Rolling updates. So let's say that you want to roll out a new iteration of a specific component. Are you able to do that in a way that ensures that there is no downtime? And then resource optimization. So the ability to scale up and down based on traffic, the ability to scale to 0 if needed. So all of those things are things that are very, very difficult to build. And most kind of large enterprises, Fortune 500 companies, when they think about dealing with these problems for traditional software applications, often they'll use a framework like Kubernetes that has a lot of that functionality out of the box. And so that's the approach that we've taken at Seldon, is to enable the building of machine learning applications, the deployment of models, but also the components around those models in a way that's production ready out of the box, where you have all of these production ready pieces of functionality without needing to build it all yourself. So here's a kind of summary of our approach and how we think about solving some of those challenges. First, we have one of our main products for kind of deployment and scaling and production is Seldon Core 2. And with that product, we enable the deployment of complex applications that include the ability to deploy individual models, but also the ability to kind of create complex applications with modular components around those models. So that includes the ability to set up pre-processing and post-processing steps, the ability to add monitoring components, and all of that is built in a way where you have Kafka under the hood, streaming that kind of data that's being communicated from component to component in real time. And then the second part I've mentioned already is the production readiness part. So this is where we leverage Kubernetes, the kind of Kubernetes first approach, where if you're building an application and you're deploying models or deploying components around those models, we enable an easy way to deploy them into Kubernetes, and then we handle the kind of orchestration and scaling around those models and components. Okay, now we're going to do a demo, a bit of context before we do that. So we recently held a hackathon, and the whole idea of the hackathon was to build AI agents with a couple of products that we have. So one is Seldon Core 2, which enables the building of real-time complex applications where you can deploy various components, connect them together, and have them running in a Kubernetes environment. And the LLM module, which offers the ability to deploy all sorts of LLMs, as well as components around those LLMs. So I will hand it over to Tonya, our lead engineer, and she's going to walk through the demo.
Not this one.
Not this one?
Hey, do you hear me? And if I will talk like this? Okay. So what we will do, we'll do a real demo and we will deploy in real time to Kubernetes cluster. So hopefully nobody will remove the Kubernetes cluster while I'm working on it. Yeah. Okay. Do you see it well? Okay. So I know Paul mentioned a few things about our main products, like Seldon Core 2 and LLM modules, but I would like to repeat a few key entities I will be mentioning today during the demo, and these are server, model, and the pipeline. So these are key entities in our Seldon ecosystem, which are enabling the deployment of ML models and AI applications to Kubernetes. And they're helping to ensure production readiness of those models at scale. So let's review them briefly. So first of all, I will be mentioning a server, which is a runtime that hosts ML models. So this is where a server get loaded and run. And it's a responsibility of our Core 2 product, which schedules models into servers. So depending on the model's requirements, for example, it could be a Python, some Python requirement. Core 2 understands which server to choose and load model to it. And during this demo, I will show that we deployed a few servers to match the requirements of our models. Then we have a model. So model is a set of model artifacts, configuration settings, and this is what we are deploying, and this is what runs on the server. And you will see that in our demo, we put all the model artifacts to the external bucket and then deploying like model manifests to the cluster. And the last one is a pipeline. So pipeline composes multiple models into a directed data flow. So in this way, you could chain different components like preprocessors, models, post-processors, and build an inference graph. And we will review this pipeline definition later in our demo. And also what I would like to mention that Seldon Core 2 responsible, like the services of Seldon Core 2, right, are responsible for orchestrating the data through the pipeline. Okay. So what we will do now, we will demonstrate how to build and deploy AI agent using Core 2 and LLM modules to a Kubernetes cluster. So our goal is simple. We would like to implement a marketing agent who takes information from the user-facing form, something like this. So you could see we have here first name, last name, some other details. And we would like to generate a marketing email tailored to the user needs. And there are a few key components that were also mentioned during that presentation, but if I'm speaking about marketing agent, of course, we will have, as I said, input from the user-facing form. Then, of course, we should define a prompt with the goal, with communication style and instructions for the agent. Of course, we will deploy LLM which will determine which tools to use in order to achieve the goal we defined in the prompt. Of course, we will define a set of tools which will provide the agent with access to external information. And of course, we need a memory component to persist the conversation history. So I will briefly describe right now the tools that we will define. So let me render this diagram. So you could see on the diagram with the green color, we have 3 tools we defined which agent has an access to in order to achieve the goal of generating a marketing email. So the first tool the agent has access to is a tool that retrieves user information from the database. Then we have two other tools that helps to retrieve marketing resources from the database based on the user needs. So I will talk about these tools a little bit later, but the most important part here that these two tools for retrieving marketing resources, they are dependent from the user information we provide to agent. Of course, on this diagram, you could see that we will deploy a component which have access to the OpenAI model. We also have a component which is responsible for prompt definition and tools definition. And there are a few other components like formatting the response. Yeah, so I will describe those later. So in order to deploy the marketing agent, we will do the following. So first of all, I will review the initial step of the Kubernetes cluster because we deployed a few things to simplify the demo. Then we will define the necessary tools and deploy them as core 2 models to the cluster. And then we will define, compose those models, right, and deploy them as a Seldon Core to pipeline to the cluster. I also forgot one thing about the model. So it's not necessary should be machine learning model. In our case, our tools just access database and return this information from the database. So you will see it a bit later. Okay, so as I mentioned before, we actually have server as a separate entity, and we already deployed it to match the needs of our models. For example, some of our models have some particular dependency, so it's already there. And yeah, you could see them here. Also, I deployed Postgres database with some information I will show right now. As I mentioned before, we have information about users in our database. You could see it's an email, company name, job title, but also we have links to the last visited pages of Seldon documentation or Seldon landing pages. And we will use this information for other tools as well. And we have another database where we have a list of marketing resources which are categorized with tags here. And it would be a responsibility of a model to choose a proper tags based on the user preferences. Okay, so let's start deploying our model. And I would like to start from the first model, which is a pre-processing step. You could see on the screen that this is just a set of like some Python files and some other model artifacts. But the main idea of this model or component is to define prompt and define a set of tools the agent could use. So you could check our prompt. We are setting up a goal here that this is a marketing agent. We're also describing the workflow for the agent, email format, and also we're describing a list of tools we are providing for the agent. And of course, like communication style. So what we will do now, we will deploy this model. As you can see, we already put model artifacts to the cloud bucket, and the only thing we should do is just call this command. Let's check. Okay, we deployed it. The next model is a model or component which should have an access to OpenAI model. So this component is provided by our Seldon LLM product, and shouldn't be necessary OpenAI model. It could be any like other open source model, but also custom model deployed locally. So this is like the brain of our agent. It uses the existing context, for example, information from the form, prompt. It decides what tool to call, and of course, it produces the end result. And all of this, of course, is persistent in the memory components to have a history of conversation. And yeah, we will also deploy this model. The manifest is pretty simple. We are just pointing to the cloud bucket with model artifacts. Now, another tool. So these tools actually allow us to retrieve some information about the user from the database. It's pretty simple. It's just taking user email from the conversation history. It's connecting to the database and retrieve user information based on this email. And of course, returning response in a format suitable for the LLM. And we will deploy it as well. Stay with me, there are a few other models we should deploy to make it work. Okay, there are two more important tools we defined in order to query marketing resources based on the user information, which was provided by the previous tool. And we also should deploy these two tools. Okay, yeah. On the initial diagram, I actually skipped an important component, which is memory component, which is responsible for persistent conversation history, of course. In our case, we decided to put this memory component before like every tool and also here, because we have to store like inputs and outputs of every tool. We actually have a goal. We aim to simplify the management of these components in the future. And we have to deploy it as well. So there are a few memory components we should deploy in order to make it work. Okay. So last two models. These two models are required just to make cyclic pipeline works. So there is one model which called loop in our case, and yeah, it just simply forwarding information from the two responses to the LLM module. And I will deploy it again as well. And the last model is responsible just for taking the last entry from the conversation and yeah, just returning it in order to get the result we want from the agent. Okay, so now we have all the tools finally. And what we should do, we should also deploy Core 2 pipeline. And what I will do, I will show you how our pipeline manifests look like. What you could see here, maybe I will scroll down. You could see here that there is, for example, a component, which is, this is one of the memory component, and it's gathering all the tensors of the content from one of the tool. And you can see that we explicitly defining what tensor should be received in this tool. And we are doing the same for every component. So this is how we actually building the inference graph. For every component, we are defining which tensors it's expecting from all other components. We also have a goal to simplify how pipelines and models are defined, as the current way requires Kubernetes knowledge, and it seems to be too granular and mistake prone. We should also deploy this pipeline. Let's wait for it to be ready. Okay. Okay, and it seems like we have a ready pipeline, which is good. So what I will do now, we'll check how it's actually working. But first, let's recall what users we have here. So we have a user, Jane, who is senior product manager, and she's interested in data-centric approach. ML Seldon is using. So what I will do, I will open the phone now, and let's try to submit some information. So what I will do, just out of the curiosity, I won't submit any interests, and what I will expect is that agent will understand from the last visited pages of that user the interests of this user, and he will call other tools with this particular interest to generate a marketing email based on these interests. So it will take a bit of a time. Okay. So yeah, we have an email. So you could see that we provided like only name and the email, but the LLM, the agent was able to get the user context that this user is working at Lego. Also, it was able to identify that this user is interested in building data-centric AI applications. And it provided a link to the demo we have. Yeah, so cool. What I also would like to show you is how we could provide observability. So we come up with two ways right now. So it's Kafka UI. So let's try to check it. Remember, we've been sending some information about the user, and we actually could see it here in messages that this is our information, and we also could see the output in the Kafka topic, which is actually our HTML, which we use for render an email. And there are also possibility to observe some messages for particular component, if I'm not mistaken. So this was one of the component, which is actually LLM, and we could check also the messages here. And you could see that, yeah, this is a prompt, but also this is information about the user, right? So yeah, this is one way to provide observability, but also what we could check is Grafana dashboard. Let me show you. There should be a few things. I will hide it. I don't know, frankly speaking, why it's not working. Maybe I'll stop here, and if it make it work, we could return to it. But yeah, it's of course possible to set up Grafana dashboard with Prometheus in order to query all those metrics like throughput, latency, CPU usages. I wish I could show it, but maybe not today. Paul, do you want to return?
Okay, I'll be very quick. So just wanted to talk a bit about what's next for us in kind of our journey in supporting these types of applications for customers. So Tonya mentioned a couple of things that are relevant here. So you saw her deploy a pipeline using a Kubernetes manifest. And of course, we know that most kind of practitioners kind of building with LLMs and machine learning models are familiar with Python. And so one of the things that we want to work on is the ability to kind of enable the building of those types of applications in a Python first way. That'll be kind of much simpler in terms of kind of defining the logic to build such applications. And we also want to enable a UI that makes it really easy to have a kind of pane of glass over what you've deployed into production, and even enable control operations in the future. And then over time, we want to build out the different components that we would support that you might want to build agents with. So of course, MCP is more and more popular and is gaining a lot of traction. And so that's one of the things that we want to integrate natively into how we build agents. So allowing kind of the communication between components of an agentic application to be done through the MCP protocol. And then over time, more integrations and components like guardrails that would be kind of components that you could take out of the box and integrate into an application much more easily. Yeah, and we'd love your input. So I know we have some time to kind of like chat and schmooze after this. So if anybody has any questions or would like to give feedback, we would love that. Thank you.
Thank you. Yeah, really great talk and demo. It's the first time I've seen that demo, actually. So yeah, very exciting. And so yeah, does anyone have any questions? Yeah.
Yeah, thanks for the talk and the demo. That's great. I just to understand, like, there are so many agent orchestration platforms, right? Even OpenAI with agent Git, it has that. So, like, what's the added ESP? Is it like the MLOps observability, and like what's just to?
Yeah, so I would say there are two things. Well, there are a few things. So I think first of all, we allow for flexibility in terms of how you would want to build an agent. And so if a customer wants to build an agent either with an OpenAI model or a Gemini model or any model that is kind of open source or developed locally, we have a kind of agnostic way of enabling that model to be deployed and for it to be kind of interchanged as the kind of brain of a given agentic application. And so if you think about users that want to avoid lock-in, that's kind of a big point. Secondly, I would say around production readiness is that a lot of frameworks out there are really great to build things quickly. But when you want to ensure that they are built in a scalable way and that you have control over how you're building them, you want the flexibility to choose whatever framework that you want, but then deploy it in a way that you know is going to be able to handle high levels of traffic and that will scale up and down based on your needs. So that's another one. And then the third one I would say is the kind of data-centric approach. And when we talk about that, it's really about kind of real-time AI applications where we're using Kafka as the kind of event streaming data bus underneath the applications that we develop. And so all the applications that we develop have that out of the box. And so I think those are kind of the main things that we see as differentiating in terms of our approach.
Hi, thank you very much. I'm curious to learn more about the outlier detector that was in one of the slides for performance monitoring. That seems like a very, difficult task, especially if it's done, online. Like you imagine, like you get a one request or a prompt. How do you monitor that, in the absence of ground truth? Yeah. Thanks.
Yeah, so at Seldon, we have libraries that we've developed specifically for drift detection, outlier detection, and explainability. And so there are various algorithms that you can find kind of through research and that are available through those libraries that do outlier detection or drift detection using various approaches. Some of them require you to actually train a model that will be used for outlier detection and drift detection, let's say, whereas others don't require you to actually train them, but what they do is they look at the data that is being sent to the models in a production environment and flag the ones that are especially different to the other ones. In terms of how, so essentially we offer kind of libraries that, oh, you're showing it. Okay, great. Yeah. So these are some of the kind of algorithms that we offer. And we offer essentially a way to deploy those algorithms in the same way that you watched Tonya deploy models or other components. And so that's kind of our approach is, you know, we offer some of these things out of the box and you can kind of deploy them within an application that has kind of many components, some of which can be triggering these algorithms asynchronously.
Yeah, that's great. Just to add, reiterate that point around most, we support through the inference graph and the pipelines, synchronous and asynchronous kind of steps. So if your outlier or drift detector is kind of computationally expensive, you can put that in an asynchronous pipeline, so it doesn't actually slow down the execution of that particular request, but it may pop up later and say, hey, you may want to check for drift in this model. Further questions? Raise your hand if you have a question. Oh, someone hiding over here, hiding from me.
Thank you very much. My question is quite a simple one, actually, and it involved the lady's use of Grafana. Now, I remember that the previous speaker did observe, and I've observed that myself in practical terms, that traditional observability tools, most cases that adhere to the OpenTelemetry models, simply do not work on this level. I was just wondering what she was trying to capture from a metrics point of view with Grafana that didn't work out in the demo.
Are you asking why it didn't work out in the demo?
Yeah, was it? Yeah, because I remember that the previous speaker, if I remember, they recollect that observability tools, traditional open telemetry tools, simply don't work in orchestration systems, inference systems like of this nature. And I was wondering what she was trying to capture with Grafana.
Oh, so in terms of what we were trying to capture, and then I'll get to kind of an answer as best as I can to why it didn't work. But in terms of what we're trying to capture through Grafana, I think the main things will be latency, so an understanding of your average latency as well as kind of your P90 or P95 or P99 latency. Second thing will be throughput, and then third will be resource utilization, so how much CPU are you using or how much GPU are you using to actually execute your workloads. Those are the main ones, but then there are other things that are important to log as well in terms of maybe like dropped requests, or even kind of like logs around the statuses of different components. So that was kind of what we were trying to show here. We found in general that our kind of the way in which we kind of use Grafana can sometimes be flaky, and so this has happened before. In terms of exactly why it was that it failed this time around, you'll have to ask the demo gods, I guess. We ran this earlier and it worked fine.
Oh,
here we go. Okay. There we go. Yeah, so here you can see some of the kind of metrics. There's kind of like CPU usage across the different components. But the idea here is that given that we are kind of executing these workloads in real time, all of that data is available in real time as well. And so that allows you to do kind of monitoring in real time around kind of the performance and what's happening with your system.
Thank you very much.
It's
and I'll take one more question if there's one more question. One on Zoom. Okay, cool. Nice one.
chat.
Okay, you can't see it on the screen here, but the question is, how do you handle governance and compliance challenges during LLM adoption, particularly with regards to right of erasure requests? Okay, so that's an interesting one. We don't handle that. The reason I say that is so we we offer the software to deploy models, and we don't offer SaaS. So our customers are taking our software and deploying it on their own infrastructure. Even things like authorization and authentication or RBAC are managed by the customers themselves. And so all the data that is being used within their systems or that is being persisted in their tables or databases are their responsibility. We only offer the software that enables them to deploy models, scale them, manage them, that sort of thing.
Great.
Cool. Thank you.
Okay, nice one. Thank you. Thanks, everyone.